All right, so we're going to review a little bit for your final exam. So start of your final exam, we are going to do factoring. So let's review factoring a little bit. This says 11x cubed minus 539x. So what would I do to factor this one completely? So you remember you always look for a common factor. So for here you have a common factor of an 11 and also an x. So when you take out an 11x, you'll be left with x squared minus 49 here. And so x squared minus a 49 can factor to x minus 7 times x plus a 7. Okay. All right, let's look at the second one here. So 2x squared plus 6x plus a 4. Let's try to factor that one completely. So what can I factor out here? I can factor out a 2. I'll be left with an x squared plus a 3x plus a 2. And then I'll try to factor that trinomial. So what multiplies together to give you 2 and adds together to give you a 3, which is going to be x plus 2 times x plus a 1. So that is factored completely there. Okay. All right. So now what about this last one here, down here? So it says x cubed minus 3x squared minus a 25x plus a 75. So let's try to factor that one completely. So if I wanted to factor that one completely, there's no greatest common factor. How many terms do I have? I have 4, so I am going to factor by grouping there. So I can take out an x squared, and then I'll be left with an x minus a 3. I can take out a negative 25. And if I take out a negative, it changes that to a minus sign. So it'll be x minus a 3. These two are the same, so we'll take out an x minus 3, and we'll be left with x squared minus a 25. But I can't just stop there. I need to keep going. So x squared minus a 25 is a difference of 2 squares. So that'll be x minus 5 times x plus a 5. All right. We also talked about rational functions. So remember rational functions, and then we had the asymptotes and all that fun stuff. Remember what makes the denominator 0 has to be excluded from the domain there. So if we just added 2 rational functions together, we have to get a common denominator here. So the common denominator is just those two things multiplied by each other. So this first one would need a x minus a 3, and the second one would need a x. So 6 times x is a 6x, 6 times a negative 3 is a negative 18. Right, so 6 plus an 8 is a 14x minus an 18 all over an x times an x minus a 3. Okay. We also talked about polynomials, so using long division with our polynomials. So if I want to divide these polynomials together, remember you do x minus a 10, and then you have x squared minus a 9x minus a 10 here. So what multiplies? So this will be an x times x is an x squared, x times a negative 10 is a negative 10x, and then remember we subtract these, so this will be a x minus a 10. So we'll just have a plus a 1, right? So that'll be an x minus a 10, and then when I subtract, I will not have a remainder. So that means that x minus a 10 is a factor. So that would mean that x minus a 10 times x plus a 1 multiplies together to give you that x squared minus a 9x minus a 10. Okay. We also talked about functions, adding and subtracting functions together. So if I have these two functions, 7x minus an 8, and g of x is going to be 2x minus a 4. And if I wanted to find f plus g, and if I wanted to find f minus a g, I want to find f times a g, we could just do those operations with each one. So f plus a g just means I'm going to add these two functions together. So I'll have 7x minus an 8 plus a 2x minus a 4. So 7 plus a 2 is a 9x minus a 12. If I were subtracting, then remember that's special because we have to have that parentheses there. Okay. So this will turn into 7x minus an 8 minus a 2x plus a 4. That's special. So 7 minus a 2 is a 5x, and a negative 8 plus a 4 is going to be a negative 4. All right, if you multiply the functions together, so you would just say 7x minus an 8 times 2x minus a 4, and you multiply those together. So 7 times 2 is a 14x squared. 7 times a negative 4 is a negative 28x. Negative 8 times 2 is a negative 16x. Negative 8 times a negative 4 is a positive 32. So then when you combine your like terms there, so you'll have 14x squared plus minus a 44x plus a 32. All right, so what if you did f of g? So remember that one. So that means that you are plugging your g function into your f function. So let's remember the f function is 7x minus an 8. So that's the f function, sorry. Should have written it like that. And the g function is 2x minus a 4. So I'm going to plug the g function into my f function everywhere I see an x. So this means I'm going to have 7 times x minus an 8. But instead of having an x, I'm going to have a 2x minus a 4. So then I'll distribute this here. So 7 times 2 is a 14x. 7 times negative 4 is a negative 28. So I'll have 14x minus a 36. Okay. All right, we also, for functions, we talked about being one-to-one. So if you are one-to-one, then you are going to have an inverse. So if I wanted to find the inverse of this function, okay, if I wanted to find the inverse of this function, then remember we're going to say y equals 5x minus a 1 over a 4. We're going to switch the variables, so I'm going to have x is going to be equal to 5y minus a 1 over a 4, and then I'm going to solve for y. Okay, so I'm going to solve for y, so I'm going to multiply here by 4. So I'm going to have 4x is going to be equal to 5y minus a 1. I'm going to add the 1 to both sides, so I'll have 4x plus a 1 is equal to 5y. I'm going to divide both sides by 5, so I'm going to get y equals 4x plus a 1 over a 5, and then we just label that my inverse. Good deal. All right, we also talked about solving log equations and exponential equations. So y'all take a second and try to do this one. So if I wanted to solve this exponential, this is 64 is what? 4 raised to the third power. So 64 is 4 raised to the third power. So this could be 4x, or 4 raised to the x power is equal to 4 raised to the third power. So my x here, then we can set our x's equal to each other. Okay, if I wanted to solve for x here, so this is a log function, so remember we turn our log functions into exponentials. So you rewrite it, so you would say 4 raised to the 4th power is going to be equal to an x. So x is just going to be 4 raised to the 4th power, which is 256. Okay, we graphed these. We graphed logs and exponentials. So you need to know how to graph a rational function, a log function, and an exponential. I will have these as multiple choice. So just make sure you know how to graph those. Okay. All right, so then we moved into the trig part of it, which is what we've kind of been doing a lot lately. All right, so if I wanted you to evaluate tangent of 45 degrees, that is on the unit circle. So tangent of 45 degrees is in the first quadrant here, right? So this is 45 degrees. The x value is square root of 2 over 2, and the y value is also square root of 2 over 2. So tangent is going to be, well, sine of 45 degrees over cosine, or y over x. So when you put that square root of 2 over 2, square root of 2 over 2 over each other, that's just going to give you a 1. Good. All right. So if we had a right triangle, and let's just call this A, B, C. So this is our right triangle ABC. And we know that side C is going to be 31.6. And angle B is going to be 22.8 degrees. Find the remaining sides and angle. So we could find angle A by just subtracting, right? So 90 minus 22.8, so that's going to be 67.2 degrees. I can find side B. Remember, the side is always across from the angle, so side B here, I could find it by saying opposite over hypotenuse. So opposite over hypotenuse is sine. So I could say sine of 22.8 degrees is going to be equal to your opposite side over your hypotenuse side. So to solve for that B there, you'll just say 31.6 times sine of 22.8. Make sure your calculator is in degree mode here. So mine is not, mine is in radian. So side B is going to be equal to 12.2. And then you could find side A. So how could you find side A? So you could use the Pythagorean Theorem here. So a squared plus b squared is equal to c squared. So you would have a squared plus 12.2 squared is equal to 31.6 squared. Not degrees. What's going on there? Squared. So 31.6 squared minus a 12.2 squared. And then take the square root of that value. So a is going to be equal to 29.1. Good deal. All right, so what about changing from radians to degrees? So if I took a radian measure pi over 12 and I wanted to change it to degrees, remember I would multiply by 180 over pi. So your pi's will basically go away. So 180 divided by 12 is basically what I'm going to do here. So this is going to be 15 degrees. All right. We also talked about graphing. So if I wanted to graph this, if I wanted to figure out what was happening here, the amplitude here is going to be 2. The period of this is going to be 2 pi divided by whatever's in front here. So it's just a 1, so the period is going to be 2 pi. So your x values are going to be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then your y values are going to be, so it's cosine of 0. So remember, cosine of 0 is 1, so 1 times 2 though, it's going to be a 2. So it's going to start at 2, and remember it repeats. So it's going to be 2, down to 0, down to negative 2, 0, and then back to 2. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we'll say this is 2 and this is negative 2. So it's 2, 0, negative 2, 0, and back up at 2. Deal. All right, we also talked about simplifying. As much as we could, so simplifying trig functions or identities and just getting them down to something else. So before I do this, secant is what? Secant is 1 over cosine. Cosecant is 1 over sine. And when I distribute this, because this is all multiplication here, I can distribute to each one of these. So this will be cosine of theta times sine of theta over cosine of theta, because when you multiply your numerators and you multiply your denominators, right? And then minus cosine of theta, sine of theta, over sine of theta. So what happens here to your cosines? They go away. What happens to your sines? So you're going to be left with sine of theta minus cosine of theta. Good deal. Let's do another one of those. So take a second and try to do this one. So for this one, I can factor. So I can factor a sine squared out. And I'll be left with 1 plus a cotangent squared. Okay. 1 plus a cotangent squared is going to be a cosecant squared. Well, cosecant is 1 over sine squared. So this will be 1 over sine squared. So sine squared over sine squared is basically just a what? 1. Isn't that beautiful? Okay. We also talked about solving trig functions. So if I had cosine squared x plus a 2, cosine of x plus a 1. So if I wanted to solve and I wanted it to be on the domain of 0 to 2 pi, I could factor this. So this will be cosine of x plus a 1 times cosine of x plus a 1, basically, right? So then you set both of those factors equal to 0. So cosine of x is going to be equal to a -1. Cosine of x will be equal to a -1. So it's the same thing, right? So on the unit circle, we've got to figure out where cosine of x is going to be equal to a -1. So cosine, remember, is the x value on the unit circle. So it's going to be at pi. So x is going to be equal to a pi here. Alright, so what if we had 2 sine squared x is equal to sine of x? If we wanted to solve this one on the interval 0 to 2 pi. So we'll have 2 sine squared x minus sine, so I want to move everything to one side, get it equal to a 0. I can factor out a sine of x here, and I'll be left with 2 sine of x minus a 1. And then I set both of those equal to a 0. So when I want to do this, I want to figure, I'm going to have 2 different solutions here. So where sine of x is going to be equal to a 0, so where is sine going to be a 0 value? So what x or what angle or radian are we looking at? So sine is, remember, your y value, so it's going to be 0 at what? 0 and pi. And then where is it going to be equal to a 1/2? So it's got to be a positive 1/2. So that means it's going to be in a positive. So it's your y value. So it's going to be either in quadrant 1 or quadrant 2. So if it's a 1/2, then that's going to be pi over 6 and 5 pi over 6. Good deal. So know how to solve. All right. We also, so I'm going to say cosine of alpha is going to be 5 over 13. Cosine of beta is going to be equal to 4 over 5. Okay. They're both going to, alpha and beta are going to be in between 0. So alpha and beta are going to be between 0 and pi over 2. So that just means, so alpha and beta are going to be between 0 and pi over 2. So that means that alpha and beta both lie in quadrant 1. Basically is what that means. Alright, so I want to find cosine of alpha plus a beta. Alright, so remember, this is the sum formula. Okay, so if I wanted to find the sum, cosine, so remember, I'm going to say cosine of alpha times cosine of beta and I'm going to subtract then sine of alpha and sine of beta. Okay, so to do this, remember cosine is x over r. So I need to find sine of alpha and I need to find sine of beta to be able to finish this up. Okay, so for alpha, I'm going to have, remember, x squared plus y squared is going to be equal to an r squared. So I'll have 5 squared plus a y squared is equal to a 13 squared. So that's 13 squared minus a 5 squared, which is a 12. I'm in the first quadrant. It helps. Everything's positive in the first quadrant. So sine of alpha is just going to be 12 over 13. Yep, y over r. Okay, for beta, I do the same thing. So I'm going to say 4 squared plus a squared is going to be equal to a 5 squared. So that's what, a 3? Yep. So y is going to be equal to a 3. So that means that sine of beta is going to be 3 over 5. So then I'm going to simplify here. So cosine of alpha is 5 over 13. Cosine of beta is 4 over 5. Sine of alpha is going to be 12 over 13. Sine of beta is going to be 3 over 5. So 5 times 4 is a 20. 5 times 3 is a 65. 12 times 3 is a 36. And a 65 here. So 20 minus 36 is a negative 16 over a 65. And that's my final answer. Okay. Alright, so then we talked about polar coordinates. So if I had the polar coordinate negative 2, 270, and I wanted to find the rectangular coordinates. Okay, so I've got negative 2 and 270 degrees. Okay, so remember we're going to look at a positive 2, right? So we're going to look at a positive 2 and then we're going to go all the way to 270, but then you're going to go back right here. Okay, so that's where the point is, and that's where now I want to find where that point is going to be on the rectangular. Well, if I look at that without doing any work, if I graphed it like this and if I looked at this, what is the x associated with this on this axis? It's a 0. And I'm up 2 units, so this is going to be a 2. Okay, so here is my r and here is my theta. Okay, so remember your x value is going to be r times cosine of theta. The y value is going to be r times sine of theta. Okay. Go down. So I'm going to have a negative 2 times cosine of 270 degrees. So negative 2 times cosine of 270. So that's going to be a 0. Here I'm going to have negative 2 times sine of 270 degrees. So negative 2 times sine of 270 is going to be a positive 2. So the x and y coordinates are going to be 0 and 2. Or 0, 2. Good deal? All right. So we also looked at changing polar equations into rectangular equations. Okay, so if I were to look here, I've got an r and I've got a negative 6 cosine of theta. So let's remember all of the things that I have. So x is going to be equal to r cosine theta. Y is going to be equal to an r sine of theta. X squared plus y squared is going to be equal to an r squared, right? And then what do I have here? Then tangent of theta, sorry, my brain. Tangent of theta is going to be y over x. So those are all the things that I have and equations that I have to use here. So I've got r is going to be equal to a negative 6 cosine of theta. Okay. What if I were to multiply r by both sides? Okay. If I multiplied r by both sides, I would get an r squared here. And then I would get an r cosine. And r cosine is going to be a what? So I could replace both of those with those two things. So r times r is an r squared, and then negative 6 r cosine of theta. So r squared, I'm going to replace it with x squared plus a y squared. And then this r cosine of theta, I'm going to replace it with that x up there. And there we go. Now we are somewhat there. Okay. So I'm going to get this equal to a 0, and then this is a circle. So I am going to move that x to the other side, and I will have to complete the square. Just with the x, not the y. So if I complete the square, I take half of 6. So half of 6 is 3. 3 squared is a 9, and I'm going to add that to both sides. So this is going to factor to x plus 3. All of that squared is equal to a 9 here. Plus a y squared, I'm sorry. All right, we also then talked about vectors. So, vectors, if I had a vector 5i minus a 2j, and vector v is going to be equal to negative 2i plus 7j. And if I wanted to find u minus a v here, if I wanted to find that vector here, I would just subtract the parts. So I would say 5 minus a negative 2i plus negative 2 minus a 7j. So this turns into a positive, so this will be a 7i minus a 9j. Okay, so you will have about 25 multiple choice questions on your final, and then you're going to have about 3 graphing. So just know how to graph. Good deal? Alright. If you have any questions about anything, let me know. Y'all have a great day.